Welcome to part 2 of using the distributive property. In this section, we will be using the going backward approach. We will now do some examples of going backwards with the distributive property. This is where we've used the GCF. So I'm just going to write this down and then we will do several examples. Please continue in your notes packet writing the examples. So, now that you have done a lot of review and you learned something new with the distributive property, let's take what we've learned and apply it. How can we use the distributive property to find or to write an equivalent expression using the GCF for 36 plus 8? Okay, the first thing that you're going to want to do is find the GCF of 36 and 8. Okay, so I would like you to pause right now and find the GCF of 36 and 8. When you have found the GCF, please go ahead and press play again and see if you are correct. Welcome back. Hopefully you found the GCF. I will do it here for you as well. So, let's see, what numbers could go into 36 and 8? Well, I know that they are both even numbers, so I can use my Looker divisibility rule and divide both of these numbers by 2. 2 goes into 36 18 times, and 2 goes into 8 4 times. Now, I should see here that I still have two even numbers, so I must continue dividing. They are both even, so I'm going to go ahead and divide them both by 2 one more time. 2 goes into 18 9 times, and 2 goes into 4 2 times. Now, I know that 2 is a prime number, so I cannot divide that by anything other than 2 and 1. So now you know that the cake is finished, and we should find our GCF. In this case, we have two numbers on the side of the cake, so we do need to multiply those two together. 2 times 2 equals 4. So our GCF is 4. Okay. Now let me show you the easiest way to change this sum into another multiplication problem. What you should do is take the GCF, write that on the side, and then in parentheses take these numbers. They should have pluses in between them because this was a sum of 36 and 8, and then you just drop these down into the parentheses. 9 plus 2. You know you're correct because 4 times 9 is equal to 36 and 4 times 2 is equal to 8. So that's how you know you're correct. Now use the distributive property to write an equivalent expression using the GCF for 16 plus 48. So we're going to do the same thing that we did before. Let's find the GCF for 16 and 48. In order to find the GCF for 16 and 48, let's divide by a common factor. These are both even numbers again, so I'm going to start with 2. 2 goes into 16 8 times, and 2 goes into 48 24 times. Both of these can still be divided. I know they're even, so I could do a 2 again. 2 goes into 8 4 times, and into 24 12 times. I still haven't finished, so let's divide both of these by 4. 4 goes into 4 once, and into 12 3 times. I have two prime numbers in the bottom layer of my cake, so that must mean that I am done. Okay, so let's go ahead and circle the side of the cake and multiply everything inside for our GCF. Our GCF is 2 times 2 times 4, which equals 16. Now we need to use that GCF to change our two addends to multiplication problems. So 16, if we change that to a multiplication problem, that would... So once again, the easiest way to write this is to remember that this is a sum, so keep your plus sign, and then take your GCF times the remaining factors. So 16 times 1 plus 3, which you know you're correct because 16 times 1 is 16, and 16 times 3 is equal to 48. That's how you know you're correct. When we ask you to use the GCF to find an equivalent expression, you can simply write it like this. If you go ahead and show us everything, like down here at the bottom, that's fine too. Last but not least, let's use the distributive property to write an addition sentence equivalent to these two problems. This is like doing what we've just done, but in reverse. This is where you're going to think about the party and think about the number on the outside of the party wanting to get in. So again, what I want you to think about is taking the number on the outside, 3. He wants to go to the party, but he has to ask 11 and 9. Over here, you have 10 who wants to go to the party, but he's got to ask 5 and he's got to ask 7. So let's do this. Remember, when we talk about asking to see if you can go to the party, that's multiplication. So we're going to write 3 times 11 plus, always keep your sign from the middle, okay, 3 times 9. Okay, this one would be 10 times 5 plus 10 times 7. Let's test these out and see if they work. 3 times 11 is 33, plus 3 times 9 is 27. 33 plus 27, add them up, 3 plus 7 is 10, 3 plus 2 is 5, plus 1 is 6. Our answer is 60. Is that the same as 3 times 11 plus 9? 11 plus 9 is 20, and 3 times 20 is 60. So this is correct. Over here, we have 10 times 5, which is 50, plus 10 times 7, which is 70. That should equal 120. Is that the same as 10 times 5 plus 7? Of course. 10 times 5 plus 7, which is 12, equals 120. Okay. What we just showed you was another example of going forward, just like we learned in video part 1. I'm just showing you again how going backwards and forwards can be done back and forth, and you always get back to the original problems. I know that this lesson is probably a little bit confusing for you and possibly a little bit difficult, but I want you to always come back to it, rewind when you need to, watch it a few times so that you really get the understanding of what the distributive property is doing. All we're doing, like I said at the beginning, is we are using a different way to express numbers. We can express numbers as multiplication problems with a common factor outside like this, or we can break it up into 2 multiplication problems and add them together. Okay? There's multiple ways to express a number. Or it can be a sum like this. This is a sum that is being represented as 2 multiplication problems with a common factor, the GCF of 3. Okay? If you have any questions, please don't hesitate to ask either of your teachers. Bye for now. Good luck on your practice problems.